Okay, so in the last lecture we had discussed about Helvak and Lenard's photoelectric experiment, and we had discussed about the potential current graph, right? In this particular lecture, we are going to discuss about the potential frequency graph. In the last lecture, I had already said one of the failures of wave theory. In this particular lecture, we are going to talk more about that. So in this particular lecture, we are going to talk about the potential frequency graph. Okay. So I request all of the viewers of this particular video to go and have a look at the previous video to have a better understanding of what is going on in this series of lectures, and also have a have a view of the experimental setup and the motto of the setup, the goal of the setup. Okay. Now, see the potential frequency graph. So experimentally, it is seen that, suppose you take an axis as we were doing initially. Okay. Here you have the photocurrent. Here we have the potential applied across the terminals. Okay. So when the potential is 0, we know that there is some photocurrent already present in the circuit. Okay. Now as you increase the potential, the current increases, and it increases in this following manner. Okay. Wait a minute. So it increases in the following manner, like something like this, and it extends like this. Let me draw it more properly. So this is the axis. Very bad drawing, I'm very sorry. Yeah. So like this, something new. Yeah, got it. Some sort of this. Okay. This is indeed a straight line like this. Okay. I'm very bad at drawing. So let me draw it once more. The last try I'm taking. Yeah. So let me do it. So this is the axis, and here you have the photocurrent, and it extends to the back like this. Yeah. Now it's kind of. Now, in this particular experiment, in the previous one, we had kept the frequency constant, and we had kept on increasing the intensity of light to see that with the intensity of light, the stopping potential is not increasing, or changing rather, which basically implies to the fact that the energy of the electron which is being emitted out from the metal plate due to the photoelectric effect, or rather due to the collision, due to the incident light on the metal plate, is not depending on the intensity of the light source. Okay. Here what we do, we keep the intensity constant and the frequency variable. Okay. So what is happening, suppose this has the frequency say nu1, let's say. Okay. Now we change the frequency, we take some other frequency mu2, and we find that the saturation current is the same. The saturation current is the same, but the stopping potential has changed at this moment. But the stopping potential has changed at this moment. Okay. If we take one more such observation, we take one more frequency. Okay, we take one more frequency, and we find the saturation current is still the same, but the stopping potential has changed. Okay, is it clear? So this is, let's say this is nu1, let's say this is nu2, and let's say this is nu3, and nu1 is less than nu2 is less than nu3. So this is, let's say, stopping potential with respect to nu1, stopping potential with respect to nu2, stopping potential with respect to nu3. So now see what is happening. Now we find the saturation current is not changing with the frequency of light. The current is not changing with the frequency of light, but the stopping potential is changing with frequency, but the stopping potential is changing with frequency. So what does that mean? The stopping potential is changing with frequency. What does that imply? So that basically implies that energy of electron emitted out due to the falling radiation, is dependent on the frequency of light. Is dependent on the frequency of light. Is it clear? Is it clear? So what does that basically mean in very simple words? How is the energy of the light, energy of the electron being dependent on the frequency and not on the intensity? So what is happening here is that, or rather, what is the a simple conclusion of this statement? If we say, what is happening is that this light which is being incident on the metal plate is acting like a bullet. Okay, the light on the incident metal plate, suppose this is the incident metal plate, this is the light ray, it is coming as a bullet, it is coming here, it is colliding with an electron, one light particle is colliding with one electron, providing it with all its energy, and with that energy the electron is coming out. With that energy the electron is coming out. This is the reason why the energy of the electron is not depending on the intensity of the light source, rather on the frequency of the light source. Is it clear? Is it clear? Got it? Now, and the reason behind that is, we have already studied in the concept of the Planck's quantum theory that energy of a photon is h nu. Energy of a photon is h nu. So this theory is kind of being verified here, because with change in frequency the energy is changing. Rather, if light would have been a wave, then this particular equation would not have been valid, because this is valid for the wave packets, or rather the quantas, the particles of light. Each particle of a light, rather each photon of a light source, has its energy quantized in the form of h nu. Only if light is behaving as a particle, we can say that the energy of the light particle is given by the Planck constant times its frequency. And experimentally we are seeing that the light is having its energy changed with respect to frequency. That means the light of the energy provided by this particular light source is in the form h nu, because it is changing with frequency. That means light is indeed here behaving as a particle. That's why its provided energy, light is the only source of energy for the electrons, right, which is being emitted out. Whatever energy is being provided to the electron is given by the light itself. So since light is providing energy to the electrons, so whatever change in the light energy will be taking place, the same simultaneous change will be taking place in the electrons itself. So if the energy of the electrons are changing with respect to frequency, that means the energy of the light, or rather what the energy source which is present in light, in radiation, is also being changed with respect to frequency. That can only happen if light is acting as a particle. Is it clear? Is it clear? If it would have been a wave, then the energy of the light would have been a function of its intensity, but it is rather being a function of its frequency, which is directly indicating towards the Max Planck's quantum theory or particle nature of light. Is this concept kind of clear? So light is basically acting as a bullet. It is each particle of light, which we call a photon. So a photon is coming in the metal plate through the light source. It is colliding with an electron, providing it all its energy, and with that energy, the electron is coming out, is ejecting out from the metal plate towards the other terminal. Now, when the potential is zero, the potential across the terminal is zero. That is, we have not attached a cell, we have not provided any potential across the photoelectric setup. Even then, the light source is coming here. The photon is colliding with one particular electron. It is providing it with energy, and this energy is making the electron eject out from its metal plate and move to the other electrode, because it might have got the sufficient energy to travel even when the potential is zero. When the potential is applied, the potential basically accelerates the electron movement. That's why the current is considerable when the potential is applied. But when the potential is not applied, one or more of the electrons might have got sufficient energy from the light source, from the photon particles of the light source, whose energy is given by h nu, to move out from the to get ejected out from the metal plate and move to the opposite terminal. It has sufficient energy to do so. Required there is no potential. Is it clear? So these two graphical explanations and the experiment given by Helvak and Leonard, they actually indicated towards the, so if I write this as a conclusion, let's say, so if I write this as a conclusion to this experiment, so the conclusion of the experiment basically gives that light is behaving as a particle rather than a wave, indicating a failure to wave theory. We will come into more details of the failure to wave theory later in this particular lecture. Okay. Or rather, if we don't go much harsh, we can also say that the wave theory of light could not explain this effect, which is actually happening, which is practically possible, practically feasible. Clear? Wave theory was unable to explain these things. Is it got? Now, considering these two experiments, Einstein gave his best ever, equation, which kind of revolutionized the world of physics. Okay. These experiments were done, but still people were not that much sure of considering light as a particle or considering dual nature of light. But these two experiments basically led to the base of people starting to take light as a particle, not only as a wave. Einstein took the bold step, the brave step, to state that yes, light is a particle, light has its independent particle nature, and we can frame an equation to understand the particle nature of light, so which we call the Einstein's equation of photoelectric current. Einstein's equation of photoelectric current. So what is the Einstein's equation of photoelectric current? To understand the Einstein equations of photoelectric current, we need to understand a few more terms. So ingredients, we may say, to understand this. Ingredients. One is threshold frequency. Stopping potential is also one of the ingredients to study this, but stopping potential we have already learned, so I'm not going into much details of that. Threshold frequency. So threshold frequency basically is the minimum frequency required by the electron to gain sufficient energy to eject out. Now see, what is the constant threshold frequency? Let me make it very clear. Suppose there is a metal plate inside which the electron is there. Okay, and this is light source. So a photon particle comes and collides with this electron, and it provides its energy to this electron. Suppose the frequency of this light source is nu 1, let's say. So the electron is now getting an energy of h nu 1. Okay. Now this energy is making this particular electron energized, but the electron is of course binded inside this metal plate. The metal is keeping its keeping these electrons inside it. It is binding these electrons inside it. So for the electron to come out of this metal surface, it needs to negotiate this binding energy of this particular metal plate. But this particular frequency is not sufficient enough to energize the electron that much such that it can come out of this metal plate. Threshold frequency is that particular frequency which can provide the energy h nu naught to the electron, which is sufficient enough or the instantaneously sufficient enough, the threshold amount of frequency, the instantaneous frequency or the boundary frequency which gives the electron just sufficient enough energy to come out of the metal surface. Is it clear? Is it clear? The concept of threshold frequency is clear. Now, this threshold frequency will provide the electron with this particular energy, and this particular energy only helps the electron to leave its metal surface, to negotiate its binding energy and get ejected out from the particular metal plate. This particular energy is called the work function. Work function. Okay, it is given as psi naught. So work function is the energy of the photon at threshold frequency. We can also define work function as the work done by the photon particle on the electron, which allows the electron to get ejected out from the metal plate. Is it clear? And this is of course equals to h nu. Got it? Now comes the Einstein's photoelectric equation. Now we know the concept of total energy, the principle of conservation of energy, we might say, principle of conservation of energy. Energy remains conserved. It can neither be created nor be destroyed, but can be converted from one form to another. Now suppose the light source of the experiment has a frequency of nu. The light source of this experiment has a frequency of nu. So the electron is getting an energy equals to h nu. Now this energy is getting divided into two parts. Carefully see. Now one part of the energy the electron is using to get ejected out from the metal plate, which is equals to the work function h nu naught, and the rest of the part of the energy, other than this h nu naught, the electron is using that part of the energy to move from the emitter plate to the collector plate, and the energy required to move is basically its kinetic energy. So the other part is its kinetic energy. So from here we can say that h nu is equals to energy of the electron which it is using as its kinetic energy plus its work function, or rather we can say h nu is equals to half mv square plus h nu naught. Is it clear? Is it clear? So we can write it like this also. Let's see. So half mv square is equals to h nu minus nu naught, which can also be written as half mv square equals to hc 1 over lambda minus 1 over lambda. Okay, so we know frequency is equals to c over lambda. C is the speed of light, and these are photon particles. Okay, what is lambda naught? Lambda naught is called the threshold wavelength. It is called the threshold wavelength. The maximum wavelength of light required, the maximum wavelength of light source required for the electron to be ejected out from its metal surface. Clear? Now see, this photoelectric equation, half mv square is equals to h nu minus h nu naught. This is for any arbitrary light source. Now amongst all these electrons which are taking participation into the photoelectric effect, one of the electrons is having its maximum velocity. As we were already discussing, every electron is not having the same amount of energy. There is one particular electron which has the maximum kinetic energy amongst all the other electrons, right? So for the electron having the maximum kinetic energy, half m velocity max So I have already discussed this. For maximum kinetic energy implies to maximum velocity of the electron is equals to h nu minus h nu naught. Now one thing we already know, see, we have the conservation of energy gives us one more thing. So we understand this with respect to gravitation. Let's suppose here is Earth's surface and here is a ball, so you throw it upwards. Okay, so it goes like this and falls like this. Okay, at the bottommost point is at its potential energy maximum and its kinetic energy zero. At the topmost point is has its, okay, sorry, my bad. At topmost point is has its potential energy maximum, kinetic energy zero, and at this point it has its kinetic energy maximum, potential energy zero. Clear? So at the topmost point, the complete kinetic energy is getting converted to potential energy, or at the bottommost point, the complete potential energy is getting converted to its kinetic energy. So we basically can say that, and throughout this particular motion, the total energy remains quantized. The total energy remains constant rather. The total energy remains constant. It is potential energy plus kinetic energy. Now we may say this maximum kinetic energy, if is stopped by some particular potential, this particular kinetic energy of the of the electron which have its maximum kinetic energy, if can be stopped using some particular potential, we know the potential is called the stopping potential, then we can say that this complete kinetic energy might be converted to potential energy due to the stopping potential, and so from there we can equate this equation as EV naught is h nu minus h nu naught, because this maximum kinetic energy is equivalent to this potential energy due to the stopping potential, right? From here we can say V naught is equals to h over E nu minus h nu naught by. This is one of the most important expressions, and this is called the Einstein's equation of photoelectric effect. This also helps us get the Planck's constant value. We can plot V naught versus nu, stopping potential versus frequency. Slope of the graph will be the ratio h upon E, charge of an electron we know. So we can obviously find the value of the Planck's constant. The y-intercept will be this. Okay, so the graph somewhat comes out like this. So this is stopping potential, this is frequency. So this graph is somewhat like this. So it's, yeah, like this. Okay, this is its y-intercept. This is h nu naught upon E. Okay, this is nu naught, and here you have theta, which is equals to tan inverse h upon E. Is it clear? Is it clear? Understood? The photoelectric equation given by Einstein is understood? Okay. Okay. This particular value gives you the form of the stopping potential. This gives you the value of the stopping potential. This is the energy required for the electron to just get ejected out from the metal surface. Okay. So when this is clear, let us first understand what is the concept of a photon at this moment. After all these observations, all these conclusions, let us understand the concept of a photon. Concept of photon. Very, very important. Concept of photon. So point number one. In radiation, matter interaction. In radiation matter interaction. That is, the light source is when considered as a radiation which is interacting with the matter, which is the metal surface having electrons. Radiation acts as if it is made of particles. As if it is made of particles. In this case, photons. In this case, photons. Number two, these photons are particles of light radiation, having certain energy E equals to h nu, corresponding corresponding to a certain frequency or wavelength. Okay, one second. Corresponding to a certain frequency or wavelength, and using the de Broglie's or de Broglie, whatever you say, de Broglie's dual nature hypothesis, de Broglie's dual nature hypothesis, we can say photon being a particle has a certain momentum given by v is equals to h over lambda. We will discuss the de Broglie's dual nature concept a bit later. Point number three. Energy of a photon is nowhere dependent on the intensity of light source. Okay, on the intensity of light source, but the photocurrent is, okay. Intensity of light source basically implies to number of photons striking the metal plate. So as the number of photons striking the metal plate increases, the number of electrons ejecting out from the metal plate increases, which is kind of, you can imagine, as a bullet action. The more number of bullet you strike on the metal plate, it collides with more number of electrons, and more number of electrons get energized, comes out and makes the photocurrent. So more the number of photons, that is more the intensity of light, more is the photocurrent, because more electrons are coming out. But the energy of the photon, or rather the energy of the electron coming out, is not being changed. That is why we have no change in the stopping potential. The photocurrent is, okay. Number 4, all photons travel with the same speed, which is the speed of light, 2 into 10 to the power 8 meter per second. Got it? Point number 5. Frequency of a photon gives it a definite energy. Which basically implies the concept that color of a light radiation or light ray doesn't change on changing the medium, because the energy of the light particle is not being changed on changing the medium. That is why the frequency remains constant, but the velocity changes. Color of a medium is due to the frequency of the light source. Sorry, not color of a medium. Color of the light radiation is due to the frequency of it. Okay. Rest mass of a photon is 0. De Broglie's dual nature also led to the concept of the rest mass and moving mass. Okay. So m is equals to m0 times, so divided by root over of 1 minus v square over c square, also written as m0 is equals to m times root over of 1 minus v square over c square. M is the moving mass or the actual mass, m0 is the rest mass. Rest mass is the mass of this particular particle when it is at rest. When it starts moving, it acquires this particular mass. Now since the velocity of the photon is same as that of speed of light, so v and c are same, so v square minus c square is 1, 1 minus 1 is 0, the rest mass of the photon is coming out to be 0. Okay, is this concept clear? The concept of photon is clear. Now next we move on to a very important concept, which is kind of the main motto of studying the light as a particle, which is the failure of wave theory. We are enjoying the failure of something very iconic. Let's see. Now why wave theory failed? Point number one. Energy of light is not related to amplitude or intensity. Now let me first write down the points and then I will be explaining the concept as a whole. Okay. With wave theory, concept of wavefront, electrons should come out in bulk. Electrons should come out in bulk. Rather, electrons come out one at a time. Okay, which implies no explanation to threshold frequency. No explanation to threshold frequency. Point number 3, there should have been a time lag between radiation and ejection of electron when wavefront is considered. As I am explaining this one at a time, let's see. Now we assume the processes as given by wave theory and we say why these things are not applicable. Suppose this is the metal surface and on the frontmost surface we have the electron layer scheme. Okay, see. Now suppose energy was depending on intensity. Okay, so brighter the light, more must be the energy of each of these electrons. Okay, and which we have already experimentally seen by the first experiment, or the first conclusion of the experiment given by Helbach and Leonard, that the energy was indeed not at all depending on the intensity of light, because we have seen this stopping potential does not change with change in intensity. But suppose we consider, now this thing we have already concluded initially. Now suppose light was a wave, so it has a wavefront. So suppose these are the wavefronts of light, let's say. Now see, these wavefronts, they will energize all these electrons at once. These wavefronts will energize or will provide energy to every electron, or a bulk of electrons rather, since I am considering these number of electrons into the player only, so I am telling all these electrons. In general words, a bulk of electrons at once, these wavefronts, because energy is in every point of this wavefront, right? Energy is in every point of this wavefront, and every point of the wavefront will come in contact with each of these electrons, so it will energize each and every bulk of this electron, or rather this bulk of electrons, each and every electron as shown in this bulk at once. And with time let's say with time, with as you keep on providing the radiation to this particular metal plate, the wavefronts keep on energizing the electrons. The wavefronts keep on energizing the electrons, and at a time, all these electrons will have the sufficient energy to come out, to get ejected out from the metal surface, and they will come out at once. But that is not happening. Electrons are not coming out at once. Electrons are coming out one at a time, because the concept is taken as a bullet action. Each photon is coming and colliding with one particular electron. It is ejecting that electron outside from the metal surface. Also, you can obviously see that when light is considered as a wave, these wavefronts take time to energize the electrons. These wavefronts take time to energize the electrons. So there must be a time lag between the radiation falling and the electrons coming out, but that is not happening. We have seen in the first graph intensity versus photocurrent. Just instantaneously as the intensity is increasing, or just instantaneously as light radiation falls on the metal surface, there is a photocurrent seen in the circuit. Is it clear? Basically, there is no time lag between the falling radiation and the photocurrent being there in the circuit. So these 3 points lead to a failure in the concept of wave theory. So let's lecture up to this much. In the next lesson, I will be trying to explain the Millikan's verification of Einstein's equation, this experimental setup to verify whether Einstein was true or not, and we will moving on to the concept of de Broglie's wavelength, de Broglie's dual nature of light. Okay. Then we will moving on to the de Broglie's wavelength concept. Okay, matter waves concept. So we will meet you guys in the next lecture.